for instance, something that looks like this. If we're given a polynomial function, and we want to be able to solve it, if the polynomial is in factored form, then we can just use zero product property, right? So zero factor is done. If it's in this format, we either can factor it if factoring is allowed, or we'd have to do the rational zero test, right? Figure out the zeros and then do synthetic division, correct? All right. Well, in this case, this looks factorable. So I am going to replace f of x with 0, and we're going to factor out an x. And when I factor out an x, I'm left with.
Can we factor out 2 x's?
Yes, you can factor out 2 x's. Thank you. So if I factor out an x squared, I'm left with, no, that's not what I wanted, though. Let's leave that as an x. Sorry. Let's factor. I'm trying to teach you a certain thing. So let's only factor out an x. So therefore, I'm left with x squared plus 3. It's kind of important that we have an x squared plus 3 as a factor. So now, what?
3x, because it's 3x squared.
That x is going to get taken
You took
to
out the
the
square.
Yeah, it's not it. Yeah, I changed the problem. Sorry. All right. So now, since I have it in factored form, I can say x equals 0 and x squared plus 3 equals 0. Right? OK. Well, this one, the 0 is easy. We already know that. Over here, to solve, I have to go ahead and subtract the 3. And now I have x squared equals -3. Now, to go ahead and finish this, I got to take the square root of both sides. And as you guys remember that I keep on highlighting, whenever you introduce the square root, you have to include plus or minus. Correct? But we have another issue, which I already kind of alluded to. You cannot take the square root of a -4, because the square root of or -3. But I'm using numbers that we know what the square root of 4 is. Square root of 4 is, we say that it's plus or minus 2. Because 2 times 2 is 4. -2 times -2 is 4. Well, there's no two numbers that are exactly the same that give you -4. It'd have to be positive and -2, which are not the same, right? So we cannot take the square root of -4 in the real number system. So what we do is, whenever you're taking the square root, is we introduce our imaginary number system. And we say, we're going to break this up into the positive real, and we're going to factor out this -1. And in the imaginary unit system, our imaginary unit for taking the square root of -1 is I. Very good. So you guys do remember some things.
So wouldn't it be plus or minus 2i?
Yeah, I mean, yes, if I was going to be doing this, yes. So in this case, since we're taking the square root, we can I could break it apart into -1. Or you guys can just agree with me that x equals plus or minus square root of 3i. Now, when we're dealing with square roots, students often make the mistake of going like this, which is totally different, right? That's now saying the square root of 3i. It's the square root of 3 times I. So to avoid that mistake, it's probably going to be better to write the I in front of your number. You guys are familiar with, we don't write x3, we write 3x, right? So we often write 3i. However, when I'm talking about square roots, just get used to, a lot of times you write the I in front, because if you wrote that and your square root went over, technically it's wrong. All right? Does that make sense? Yes? It's not it yet. Saying, oh, it's just okay. All right, so everybody kind of understands that, right? Kind of a little bit. So I could write this also as my factors. I could say 0 equals x times x plus I square root of 3 times x minus I square root of 3. If I was asking you, if they say write them as the linear factors, do you guys agree that all of my factors are linear? Yes? They all have a multiplicity of 1. Everybody agrees with that too, right? OK, but there's a couple things that are important about this. And the important thing that we're going to talk about is the fundamental theorem of algebra. I'll just write it out. And I'm going to abbreviate a lot of stuff in it. Fundamental theorem of algebra. And what the fundamental theorem of algebra states, which is very, very important, what the fundamental theorem of algebra states is the degree of a function has that many zeros. That's the basic of it. The degree of that function has that many zeros, or x-intercepts, or solutions, so forth. So there's 3 solutions. However, that fundamental theorem of algebra does not tell you what type of zeros there are. We've already discussed rational zeros, right? We like rational zeros. Those are numbers and fractions. Those are easy. But then we also try and talk about irrational zeros, the square roots. Yeah? And then today we're talking about complex zeros. So you could either have rational, irrational, or complex, positive and negative. Yes?
Do you mind, would you mind writing down the definition of fundamental?
Yeah, I'm going to write it down here in a second. But what I want you guys to understand is, notice how I have one real and I have two complex. Right? One real plus two complex gives you how many total zeros? 3. That is the fundamental theorem of algebra. It's always going to be true. Always. And the other thing I want you guys to think about and write down, I'm not going to write it down in there, but I want you to write it down and to think about it, is complex zeros always come in pairs. It's either you have 2 complex zeros, 4 complex zeros, or 6 complex zeros. You cannot have one complex zero. Because remember, where do complex zeros come from? Taking the square root, right? The square root of a negative number. When you're taking the square root of a negative number, you're including plus or minus, right? So always complex numbers are going to come in pairs. So the fundamental theorem of algebra basically states that the degree, fundamental theorem of algebra has same number of zeros or solutions as its degree. That's basically what it says. OK? Does that make sense? Kind of?